Welcome, and today we're going to learn about combinations and compositions of functions. When combining a function, you can add, subtract, multiply, or divide the function. Let's do some examples. This first one, we're simply adding the functions. Don't forget to combine like terms, as you see 2x plus x makes 3x. Tricky thing about subtracting functions is that when you subtract a function, you subtract everything in the function. So you should distribute that negative and make that minus 1. When multiplying functions, you just simply distribute or Punnett square if you need to. And when dividing functions, all you do is make sure you say what the domain can't be. So in this case, if we plugged in -1, we'd have a 0 on the bottom, and that would be a problem. Pause the video for a moment and try the next 4 on your own. I'll then show you how to do them, and you can come to class with questions later. Alright, did you try them? Here are the answers. For the first one, you're simply combining like terms. For the second one, don't forget to distribute that negative. For the third one, you'll need a 2x3 Punnett square. I skipped a few steps there. Hopefully you figured that out on your own. And for the last one, I actually ended up factoring it. Oops, seems like, yeah, I factored it and showed what the domain can't be. 1 and -2 would both make the denominator 0. Try this next part on your own before coming to class, and we will discuss those 4 in class. For the next part we're going to learn about, we're going to talk about composite functions. That's where you plug one function into another. Here's our little function machine. Let's say we've got x plus 2 up there as one function and 3x as another function. I input 5x into the first function and you get out 7. If you took that and plugged that into the next function, you would get out 21. Alright, that's a simple illustration of the idea we're trying to illustrate here. If we call the functions f of x and g of x, then we say f is plugged into g as a function. The notation there is g of f of x. Notice that f of x is on the input of g of x. Let's do another example using our diagrams again, but this time we're going to swap places. So we'll have g of x first, followed by f of x. And we're going to take the same number, and I'll show you that the order really does matter here, because if you plug in 5, well, you first get 15, take 15 and plug that into f of x, you get 17. So clearly you get a different output. So that means g of f of x is different than f of g of x. Let's do some examples. One quick note, if you notice, there's a difference between what the notation the textbook uses and the notation I tend to use. The textbook uses the first one, I use the second one. They mean the same thing, so don't let that trip you up, okay? If you're doing problems in the textbook, just switch it to my notation if you like mine better, and we can talk about why I like mine better in class. Alright, let's do some examples. The important thing to remember here is you're taking the entire function and plugging it into the other one. So I'm going to use different colors for the input and the output. So with f of g of x, notice how g of x get puts in the input everywhere that the x occurs for the f of x function. And I hope I made that pretty clear. That last step would be fully written out, and with a little manipulation, you want to distribute the 3 and then subtract that 4. You should get that answer in purple there. Alright. For the second one here, all I'm going to do, they just switch the g and f to show you it's different. I'm going to write the outside function first and leave f of x as an input. Plug that in everywhere you see an x. When you plug that in, you will need to Punnett square that, and that's just a bunch of algebra manipulation that you guys can do, and you should get that answer in purple down there. Okay. For the third example, we actually plug a number in. So what I'm going to do is I'm going to plug it into f first, since the input gets put into the input of f, and you get 3 times 1 minus 4. You then take the answer of that, which is -1, and plug that into g, and you get 9. And now I skipped showing that step because we've done functions and you guys know how to plug numbers into functions. A way to check that is, you notice g of f of 1, we could just take that 1 and plug it into the second example problem, the 9x squared minus 30x plus 30. If you plug 1 in there, you should get the same answer, and that's a great way to check it, especially on quizzes if I give you more than one that's kind of similar like that, you know. So pause the video for a second. I want you to try the next 3 on your own. Once you're ready, unpause it and I'll show you the answers. Alright, did you try it on your own? I really encourage you to try these on your own, because the more you work and learn on your own, the better you'll do when it comes to class. So, let's look at this first one. Notice I'm trying the other way, I'm showing you the other way to do it. What you can do is, before I was writing the outside function first and just writing each g of x as an input inside of it. This time I wrote the g of x, changed that first, and I left f of x on the outside, and I'll plug in my giant ugly function into everywhere of f of x. You get the same answer either way you do it. It's just a matter of preference. For the second problem, it's a little trickier because you're plugging in 5x plus 6 everywhere you see an x. Notice that there were 2 x's in that function, so you want to plug it in both places. And again, I skipped all the messy algebra, but you should have gotten that answer on the bottom there. For the third example, I am going to actually do it the other way I talked about. I'm just going to take -1 and I'm going to plug it into what I just got, that equation. If I already did a bunch of work, why waste that work? Just use it. And in this example, funnily enough, you get exactly 0. Alright, try those last 3 on your own, and do those before coming to class so we have something to talk about. Alright, this very last part is breaking down functions or decomposing functions. It's just a fancy way of saying that you're going to do the opposite of what we just did. You're going to take a function and you're going to break it into other smaller parts. Now recognize, the student will recognize that you can do this in more than one way. Especially the more complicated the function, the more ways there are to do this. So if you discover a different way when you're doing examples, show me if you're not sure if it works, and I can tell you if it works or not. So, for example, this first function, h of x, we're going to change it into f of g of x. Alright? If we say g of x is equal to 3x squared minus 4x plus 1, that can be put on the inside, and you see the outside function is just something to the 5th power. So if you plug those in, like we did before, you can check your work, and you should get 3x squared minus 4x plus 1, all of that to the 5th power. Try breaking down the next one on your own, and pause the video, and I'll give you a second, and once you get it, then you can unpause the video. Alright, hopefully you got this answer. We can use f of g of x, so g of x should be x squared plus 1, that's the inside function, and the outside function is the cube root of x. Alright, again, try those last ones on your own before coming to class, and I hope this video was helpful. You can obviously pause or replay any part you need to, and please come with questions to class. Thank you.